This is a video about precision and accuracy. In this video, I will be using 3 new words with great frequency. So the first thing we're going to do is write down their definitions. The first word I'm going to be using is precision. It refers to the level of detail in a measurement and is determined by the smallest unit or fraction of a unit that you can measure. So for example, it's more precise to measure in inches than in feet, and it's more precise to measure in tenths of a pound than just plain pounds. Second, we'll be talking about accuracy, and that's the closeness of a measured value to the actual or true value. So, if you have a 5-pound bag of flour, a measurement of 5.2 pounds is more accurate than a measurement of 5.5 pounds because it's closer to what it's supposed to be. And finally, we have tolerance. Tolerance is the amount by which a measurement is permitted to vary from a specified value. So if I have my 5-pound bag of flour and my tolerance is half a pound, it would be okay if I said it weighed 4.5 pounds because that would be inside my tolerance, but it wouldn't be okay for me to say that it weighed 4.4 pounds because that would be more than half a pound away, so I wouldn't tolerate something that far away. We're going to look at these words in action. The first thing we're going to do is look at precision. So I ask you to choose the precise measurement, and you can tell whether or not measurements are more precise, as I said before, by a more precise measurement will use a smaller unit, or it will also use smaller fractions of units to measure. So in number 1, when I'm comparing 0.8 kilometers to 830.2 meters, I am automatically going to say that 830.2 meters is more precise because it uses meters, which is a much smaller unit. Using a smaller unit lets you get more detail in your measurement. Now in number 2, when we're comparing 2.45 inches and 2.5 inches, they're both in the same unit. But 2.45 inches is more precise because it's measuring to 2 decimal places, or in hundredths, whereas the 2.5 is only measuring to 1 decimal place, or in tenths. So we're getting more detail in the measurement by going all the way down to hundredths instead of just stopping at tenths. So a good takeaway about precision is that precision always means more detail, using a smaller unit or a smaller fraction of a unit. Now we'll look at accuracy. Sarah works in a deli. She is testing the scales at the deli to make sure that they are accurate. She uses a weight that is exactly 1 pound for her test and gets the following results with their 3 scales. The first scale says that the weight weighs 1.019 pounds. The second scale says that it weighs 1.01 pounds, and the third scale says that it weighs 0.98 pounds. Which scale is the most accurate? Now the first thing we need to remember is that accurate means which scale is giving us a measurement that is closest to the true value. And in our case, the true value is 1 pound. So this is what we're looking for. So we want to know which measurement is closest to a pound. The way we can find the distance from 1 is doing the absolute value of what the scale told us minus 1. So if I do the absolute value of 1.019 minus 1, that's going to give me 0.019, and absolute value gives me positive 0.19. If I do 1.01 minus 1 in the absolute value, that gives me 0.01. So the absolute value of 0.01 is 0.01. And then if I finally do 0.98 minus 1, that gives me negative 0.02, but absolute value gives it positive 0.02. So I did the absolute value because I just care about the difference, not whether it's positive or negative. So these are my 3 differences. And what I'm interested in is this distance, 0.01, because that's the smallest. So that means that scale 2 is the most accurate because its measurement was closest to the true value of 1 pound. Now to show how accuracy is different from precision, I just want to mention that the most precise scale would be scale 1 because it's the only one that measures in thousandths. The other ones measure in hundredths, so it goes out to 3 decimal places. Now that we've looked at precision and accuracy, the last thing we need to look at is tolerance. So our fourth problem says a lacrosse ball must weigh 5.25 ounces plus or minus 0.25 ounces. So this is an example of tolerance. This is saying 5.25 ounces plus or minus 0.25 ounces. This is saying that the tolerance is that it can be 0.25 ounces above or 0.25 ounces below 5.25. So this table on your screen gives the weights of some balls in one box. And our question is, do all of the lacrosse balls weigh within the specified tolerance? Are they no more than 0.25 ounces above 5.25 and no less than 0.25 ounces below 5.25? The way to figure this out, I think the easiest way, is to think about what would be the highest tolerated value and what would be the lowest tolerated value. So the highest tolerated weight would be what it's supposed to be, 5.25 plus 0.25. And so that gives you 5.50 ounces. And the lowest tolerated weight would be 5.25 minus 0.25, and that would be 5.00 ounces. So we need our lacrosse ball weights to be in this range. If it's not in that range, then they don't work. So as I scan my list, 5.41 works, 5.323 does work, but 5.54 is above 5.50, so that doesn't work. 5.33 works, 5.21 works. So all of them except for C does not work. So we would say that this value does not fall within the specified tolerance, or it does not meet the specified tolerance. And we'll end with one other tolerance problem. The amount of vitamin A in a gummy vitamin should be 5 milligrams, but it is permitted to vary by 0.5%. We want to write the possible range of values allowed by the tolerance 5 milligrams plus or minus 0.5%. Now, the problem with doing this is that they don't give us the tolerance in milligrams, they give it in percent. So before we can do anything, we need to know what 0.5% of 5 is. So to do that, we're going to multiply 5 by 0.005, because to turn a percent into a decimal, we need to move the decimal places 2 places to the left, so I moved it from here to here. And then we multiply and get 0.025 milligrams. So now that we know that this is actually 0.025 milligrams, we can find the highest and the lowest tolerated values. My highest value will be 5 plus 0.025, which is 5.025. And my lowest will be 5 minus 0.025, which is 4.975. So my range of permitted values is 4.975 milligrams to 5.025 milligrams. And thus ends our video on precision, accuracy, and tolerance.